Hello and welcome back to the bare metal programming series where we're building firmware for a Cortex-M4 STM32 microcontroller. This is episode 9 and today we're actually kind of filling in the very last piece of the puzzle we need before we can write the firmware update mechanism for the bootloader, and that is some kind of high-level timing API. Now, we've talked a little bit about kind of hardware peripheral timers in the series before when we looked at PWM, and we've also looked at the SysTick, which is kind of a system-wide kind of relatively low speed timer that you can set up, which you can receive an interrupt for, and you can use that for kind of timekeeping across the whole chip. Now, what we're going to be doing today is kind of building on top of that SysTick timer and building something where instead of kind of manually checking like, okay, how many ticks have passed since the last time I checked? Oh, it's been this many. Okay, how long did I need to wait? And kind of doing this manual calculation each time. Instead, what we're going to be doing is building up a timer API and just being able to create an instance of that. And then we'll use a couple of functions like initializing and checking if something's elapsed and resetting. And we'll use that interface in order to interact. And the big reason that we're doing this is because in the bootloader, the firmware update mechanism, the idea is going to be that we come into the bootloader and we just sort of try to see if anyone's trying to send us an update. That's going to be the mechanism. There are plenty of mechanisms you could employ, but this is the one we're going to go with. So we're going to be able to reset the chip, be looking out for a firmware update, and if a certain amount of time passes and we just don't hear from anyone, then we're going to want to just jump into the application and not waste any more time. And we're going to be able to want to be able to do that kind of across a whole set of steps. So if we don't hear any packets on the communication line for a long time, then we can also, just exit out. But in order to do this, we kind of need some sort of nicely organized timing capabilities. So let's take a look at the plan. Let's see what we're going to do today. All right, so Episode 9, perfect timing. Create a simple timer API which allows for setting a timeout, checking if it's elapsed, and resetting the timer, accounting for drift. That's kind of it's a nice to have, but it's something that I think is kind of cool that we can do. And that is that if you're actually having a timer that's going to be used across many different intervals, right? We want to be able to check if the timer has elapsed, and then immediately sort of start checking for the next time it will elapse. So every second or so, maybe we want something to happen. We want to be able to create a timer that says, every second, tell me if I've elapsed, and if we happen to have taken too long, and we kind of, instead of waiting a second, we waited like 1.1 seconds, well, let's account for that drift, and not wait a full second the next time, but instead wait 0.9 seconds, and that way we don't we get kind of closer in to where we were trying to be on our timing. So that's something we're going to be doing. And the steps, well, we're going to build up a structure, we're going to build some functions, and we're going to test it out. It's actually not going to be too complex today. This is going to be kind of the last nice simple thing that we knock out before we go into the main interesting part, which is building the actual bootloader state machine in episode 10. Okay, so let's not waste any time. Let's just get straight into it. I am going to put this timer into the shared utilities because I think this will be useful to use in the firmware as well as the bootloader. The firmware already has something that's kind of happening like this. So I'm going to call this the simple timer.h. So it's the humble simple timer. It's not an advanced timer. It's not a hardware timer. It's just a simple timer abstraction. Let's start off with a structure definition. We'll call it simple timer T. And what do we need to keep track of here? Well, we're going to need to bring in common defines because without common defines, we don't have any conception of what a uint is or something like that. So what we need to keep track of, and remember what the system keeps track of in terms of ticks, like how this is the SysTick handler, and every time we get a SysTick interrupt, we add one to the ticks. And the way we've set this up is that we get 1 tick per millisecond. So 1000 milliseconds in a second. So we get a per tick situation, and the kind of enclosing type of the SysTick handler is a uint64. So that means that effectively it will never run out, it will never overflow. Okay, so what we're going to have then is uint64 be our kind of base number here. And we're going to have a kind of a wait time. So this is going to be like, hey, every second I want something to happen. The second, that's going to go in the wait time. It may be that your timer is much longer than that and actually is like weeks long or something like that. You might have a bit of loss of precision if you do that with this microcontroller because it's not intended for this purpose, and of course timing can change with temperature and environment, so you wouldn't have a very accurate timer. But if that's not important, you can have a short timer or you can have a long timer, and you can do both these things this way. So this is going to be our kind of our interval, our wait time. Then we're going to have a kind of this is going to be sort of convenience part here. We're going to have a target time. So this is basically the actual kind of concrete number of system ticks that have passed. This is like referring to that. So when we set up our timer, we'll be kind of taking into account like how many ticks have passed right now, kind of plus this wait time, and that's our target time. And then we want to have a field which will be auto reset. So this will just be true or false, and like if it's true, if we're automatically resetting, then the idea is that when we check the timer to see if it's elapsed, as soon as we check it, it will set itself again, and it will be ready to be checked the next time around. It won't require any kind of interface from the user to say, and now reset the timer. Of course, you might not want to have an auto reset timer. You might want to just have a normal timer. So auto reset, it's something we're going to add as an option. Okay, and maybe we also want to have an account for drift operation, Boolean. I'm going to leave that out for now. Okay, so what functions are we going to have? We're going to have a simple timer init, or rather, let's call it setup. So everything else is called setup. And for that, we will take a pointer to a simple timer, call it timer. Don't implement it in here, this is just our signature. Then we are going to have a Boolean function called simple timer has elapsed. So that will just tell us true or false, have we waited enough time? And then let's have one more, which will just be reset. And then we'll just reset the timer. So when we do the setup, we actually need a few more parameters than just the timer itself. We'll of course need a wait time, and we will need an auto reset boolean. Okay, so this is the interface. So I'm going to copy this, and I'm going to put it inside simple-timer.c. include simple timer.h. I'm going to implement these. Okay, it's now found that. So the setup, what are we going to do here? Well, we're going to take our timer and we are going to set the wait time. So that's going to be wait time. Then we're going to set the auto reset to auto reset. And then finally, we're going to need to kind of work out the concrete target time. And for that, we need to bring in core system, right? Because system includes our getTicks function. I don't know what changed in this file. Okay, so timer target time is going to be system getTicks plus the wait time. That's all we need to do to set up the timer, I believe. Okay, and then we're going to have, has the timer elapsed? This is actually going to be a little bit trickier than you think. You think you could just have a one-liner in here for return and then move on. But actually, because we're going to have this whole auto reset mechanism, this is going to be a little bit more involved. So what we're going to do is we're going to open up by creating a variable called now, which is just system.getTicks. This is going to be now in the moment that we're checking this. Then we're going to have a check for if it's elapsed. So basically, if now is greater than or equal to the target time, so timer target time, if it's greater than this amount of time, then we know that that amount of time has passed. So we can then also compute a delta, like a drift. Let's call it drift. We only need to do something with drift in this case. So let the compiler deal with this stuff. So the drift is going to be how far ahead is now than the target time. So effectively, this drift is the amount of difference for if we're going to reset the timer, like our new the new time we're going to wait, like how far do we have to go. So what we're going to do is so this is actually, you know what? Let's put a bool has elapsed. This is if it has elapsed, and this is if it has elapsed and the timer has auto reset. So only in those cases. So if we have auto reset, then the new target time is basically now plus timer's wait time minus the drift. So we're just now accounting for this drift. So we're waiting a little bit less time next time. And that's how we can do that. And then we finally just return has elapsed. So that is our timer elapsed. And then when we go to reset the timer, it's actually really straightforward. The target time, well, we can actually just call our simple timer setup, actually. It's kind of, I think the compiler will probably inline this for us. We can just pass in the timer with the timer's wait time and the timer's setting for auto reset. And even if it doesn't inline it, this is kind of still fine. All right, that is good, I think. So let's test this out. We can test it out in the firmware or the bootloader. I think I'm just going to test it out in the bootloader because it's already kind of just in a testing state. So already put this in the make file. So simple timer. And in the bootloader.c file, let's get rid of our flash test. And we can create ourselves a simple timer. And the wait time, I want to do something that's like observable. It's kind of like easy for us to see while we're testing this. So I think just 1 second is a good interval for checking. And we can change this value in a bit. And let's say that auto reset is on true. Then we can see the auto reset mechanism working correctly. So what we're going to do here is just in this while loop, we will check if simple timer has elapsed. Pass in our timer there. Then we're gonna do something inside here. So what I'm going to do is I'm just going to create a volatile variable. Increment it, and then put a breakpoint here. But instead of doing a breakpoint, let's use a log point, which we've seen here in a previous episode. And what we're going to log is just the timer elapsed. So now we'll just get a nice visual, simple thing without having to do anything with the hardware. without having to see it specifically or get any other kind of peripherals involved. Okay, so I'm going to run the bootloader. So then we have GDB open here on the bottom, and if I just let that run, okay, we don't see it because we need to open the debug console. If you look here, this number is going up once per second. Great, that looks good. It looks like we're actually waiting the right amount of time. Let's change this to 500 and see that it goes up twice per second instead. And we'll open up GDB, sorry, rather the debug console. Yeah, that looks about 2 Hertz to me. So this is actually working correctly. And what we could do, right, is that one change we could make is the thing is now it's actually if we take this true out, we make it false instead. Let's put this back to 1 second. It's probably going to do something that we might consider to be unusual, and it kind of just depends on your perspective. But it's going to run. I think I removed the log point, didn't I? Okay, yeah, that's kind of not very useful. Let's put it back for a second. Elapsed. Okay, let's put this back and let it go. So then it goes once, but then it's just going a whole bunch. And the reason is, of course, every time we enter this while loop, this is always going to be true. So what we might want to have is that if the timer elapses and we don't have auto reset enabled, then we might actually want to like not have this condition evaluate true anymore. And that's kind of we can make this timer more and more complex, but we could add different options for it. But what I think I'm going to do is that if the timer has elapsed and well, you know what the simplest thing to do is? Let's just add another boolean, which is called has elapsed. And we will go into the simple timer. By default, has elapsed will be false. And what we're going to do is if the timer has elapsed and if we have auto reset, then we'll do these things. And otherwise, we're going to just set that the timer has elapsed. And before we get to any of that stuff, we'll check this. We'll say if timer has elapsed, just return false. So this is going to be a way of kind of short-circuiting that. So this is going to make sure that we kind of have a one-shot thing going on if we have a no auto reload. So let's check this. What we should see is that this fires once and once only. So let's run this. Open the debug console, press play, and roughly 1 second it elapses, but never again. Okay, great. And then what if we did make a volatile int x? You know what? Let's make this even fancier. Actually, we don't. Let's put that back there. What we're going to do is have another timer. Let's call it timer 2. And timer 2 is going to be on a different interval. So every 2 seconds, and this is going to be an auto reload. We're going to say if simple timer has elapsed, timer 2, then we're going to reset timer 1. So we'll do simple timer reset timer 1. Okay, so now what we should see is that every 2 seconds, effectively, we get one of these logs because we have one timer triggering the other one. It's kind of a contrived example, but I think it will allow us to explore the full API. So let's go into the debug console. We get a one elapsed message. Now we get another one. We get another one. Perfect. So everything, as far as I can tell, is working exactly as expected there. Alright, so as far as I'm concerned, I think we can draw a line under this feature as well. And we now have everything we need in order to create a proper firmware update mechanism. So in the next few episodes, I think this is going to take us probably at least 2 episodes to implement, and maybe an extra to test. Over the next 2 episodes, we're going to do 2 things. We're going to implement the bootloader firmware update mechanism in the firmware, but I think it's also going to be useful and kind of nice to do the other side as well. So I didn't write the very first iteration of building the packet protocol, but I think it will be worth writing the code for the firmware update mechanism in TypeScript, which is the programming language we're using for the update mechanism. And then I think in the 3rd episode we can do the testing and the bug fixing. And at that point we will have the very first kind of large milestone of this project complete, which is we will have a updatable bootloader system. We'll have a bootloader and a main application and an easy way to update over UART, just like the Arduino. And then from that point on, of course, then we're going to move on to the next goals, and things are going to get a little bit more advanced. But let's not set our sights too far ahead. Let's just get this done first. So if any of this from today or any of the previous episodes hasn't made sense to you, please feel free to leave a comment, and please feel free to join the Discord server and ask any questions that you may have there. Until next time, thanks for watching, and I'll see you in the next one.